All right, we are reviewing for our test. This is about halfway through the chapter, 4.1 through 4.4. Then we'll have another test after we get through the second half of this chapter. Obviously, it's a long chapter. So as we start to review, I'll try and run through the things that we've covered before, and then you will do a couple of review guides and ultimately take our test next week, or the end of, next week. Wednesday or Thursday. So, the first thing we're going to talk about is end behavior. Okay? And end behavior is if we have a polynomial function, the question is what does that polynomial function, see if I make this a little bigger, look like? How could we describe what it looks like on the ends? Okay? And so, these are just some rules that we have to memorize. But if the degree is even, now remember degree is the highest exponent in our function, and if it's an even number, so we're talking 2, 4, 6, 8, 10, 12, anything that's divisible by 2, and the lead coefficient is positive, the number in front of the polynomial, then the polynomial's ends both go upward like this. Makes a field goal. Okay, if the degree is even, or is even again, so 2, 4, 6, 8, 10, 12, just like before, but the lead coefficient is negative, should have highlighted the positive part in the first one. The lead coefficient is negative, both ends go down. Okay, so that's for our even degrees. If we have an odd degree at the beginning, and lead coefficient is positive, then you can see the ends go in these opposite directions. Now, one of the things I want you to note is that when we deal with positive lead coefficients, the right-hand side always goes up first. Then the left-hand side does what it's going to do based on whether that degree is even or odd. If it's even, the left-hand side also goes up. But if it's odd, then the left-hand side goes in the opposite direction. Okay? When we have negative lead coefficients, the right-hand side is going to go down first. You can even see down here, the right-hand side goes down first if the lead coefficient is negative. And then the left-hand side depends again on whether it is even. If it's even, left-hand side does the same thing. If it's odd, left-hand side does the opposite thing. Okay? So what you want to think of to help remember this is if you have an even degree, the ends do the same thing. They either both go up or they both go down. How do we decide? Positive things make this nice smiley face with the arms. It's positive. Negative things make an upside down sad face. All right? And then if we're odd, they do the opposite. One goes up, one goes down. How do you decide? Well, positive ones, again, the right-hand side goes up, just like it did for positive with even leads. Okay, so it's like you're trying to smile, but the other side's kind of making a frown. Okay, right up, left down. And then on the other side, if it's odd, the right-hand side goes down, left side goes up. So let's look at this in practice. So here I've got on the right-hand side here, let's make it a little bit bigger so you can see it. I have a function graph. Now this function f of x, it's in red here. And I've got it set up so it's ax to the b power. And right now, if you look at the numbers below that, it says b is 2. So b is the exponent, and it's even. Okay, so it's going to make the smiley face maybe. Let's see what the a value is. A is 1, which is positive, so it's even. Exponent positive lead coefficient, so it makes a smiley face. Okay, and as long as that a is positive, the lead coefficient, it will get narrower as a gets bigger. However, it still stays both ends going up. Okay, now I'm going to go to negative a values, so a negative lead coefficient, and you'll see now both ends go down. Okay, and it does not matter. I'm going to make it a smiley face again by making a positive, and I'm going to make b another even number. Let's make it 4. Okay, so now b is to the 4th power. Both ends go in the same direction. Okay, I'm going to change my b here because b, the lowest we're going to have it go is 2. Because it's our exponent, it's got to be a positive number. And we'll make it go up to 10 if we want to, just for fun. Okay, so as long as my b value is even, both ends go in the same direction. Why do they both go up? Because my a value is positive. I'm going to lower my exponent down to just a 2 because those show up best. Okay, and I'm going to use another even or another positive a value. Okay, so as long as a is positive, both the ends go up. Doesn't matter. Oops. Gotta make sure my exponent is even. Now, so ends go in the same direction when my exponent is a nice even number. Let's do some negative a values. So I'm going to lower it now. Here we go. There's a negative a, negative lead coefficient. No matter what, both ends go down. Why do they both go down? Because the exponent is even, they have to go in the same direction. The negative lead coefficient makes them both down. Now it's positive lead coefficient. Now it's negative lead coefficient. Okay, so now I'm going to start now with a positive lead coefficient. The right-hand side, if your lead coefficient is positive, will always go up. And now I'm going to look at odd exponents. There's 3. Right-hand side still goes up, but now the left-hand side does the opposite. Here's 5. Exponent of 5, that's odd. A is a positive number, and so right-hand side goes up. 7, right-hand side goes up, left side down. 9, right-hand side up, left-hand side down. Okay, and that will always be the case if you have an odd exponent and a is positive. Let's make another a that's positive. Let's do, I don't know, let's go crank it all the way up to 5. 5 does change it just the way it looks a little bit. Okay, you can see it getting narrower kind of as 5 increases, or as a increases. But the right hand still always goes up. Left hand side will do the opposite because our exponent is odd. Let's see if we can get it to flip now. I want the right-hand side to go down first. Okay, that takes a negative exponent, or a negative lead coefficient. So there we go. Lead coefficient is negative. Now the right-hand side goes down first. And left-hand side has to do the opposite because my exponent is 9. That's odd. As soon as it goes to 10, let's change my exponent to 10. Now they both do the same thing because it's even. Odd, they do opposite things. Negative lead coefficient says the right-hand side goes down first. Another odd exponent, right-hand side goes down first. Another odd exponent, right-hand side down first. Odd exponent, right-hand side down first. Even exponent, right-hand side down first. But now the left-hand side also goes down because it's even. I want both to go up. Fine, I've got to have an even exponent, which 4 is, and I need to have a positive lead coefficient. If I want the right-hand side to go up and the left-hand side to go down, my exponent has to be odd, even coefficient, or positive coefficient. Okay, so that's what we're looking for. And we can base all of this just on looking at the polynomial equation. We don't have to graph it to know this now. So let's look at the type of problem we can answer now with this. Okay, so here we have a polynomial function, f of x equals 3x to the fourth plus 2x squared minus 4. So what we want to focus on first is make sure it's going in decreasing order. So it's x to the fourth, x squared, then our constant term. And let's look at our lead coefficient. I'm going to use some abbreviations here. Lead coefficient is equal to whatever's in front here. The highest degree exponent is 3. And our degree is the highest exponent, in this case 4. Okay, so our degree is even, and our lead coefficient is a positive number. We don't care if it's even or odd. We care whether lead coefficient is positive or negative. And so right away, this is going to be a smiley face. And it's a good idea to just draw a quick sketch of what it looks like, because it's going to help us answer these two questions above. Now, you don't draw a perfect graph of this. You just draw a little sketch of it. Degrees even, that means it either does this, it makes a smiley face, or it does this, it makes a sad face. Because the lead coefficient is positive, the right-hand side goes up first. So it is going to definitely be this one. Right-hand side goes up first, and because degree is even, left-hand side does exactly the same thing. Had that been an odd degree, left-hand side would go down. Okay, so that's what our sketch kind of looks like. Doesn't matter how you draw it in there. And now we can answer the questions. And this notation is difficult because it's brand new. You guys have seen it only once before when we went through this. All it says here is as x goes towards positive infinity. So as x gets really big, okay, so x is really small over here, negative numbers. Then it hits 0 right there. Now x goes 1, 2, 3, 4, 5, 6, 7, 8, all the way out to infinity. So as x gets really big, what does the function do? And all you got to do is kind of start at the break point. Okay, the lowest point or the highest point on your graph. And you just kind of trace it to the right you want to go, because you're going to positive infinity, bigger x's, and you just say, well, where does the function go? What happens to the y values? These are the y values or the f of x values, because y and f of x mean the same thing. As x gets big, where does the y go? It goes up in the positive y direction, and that is positive infinity. So we just put it goes to positive infinity. And then I start at that lowest point, and I say, well, what does x goes to the negative infinity? As I get really, really negative, where does it go? Well, it still goes up and up forever, so it also goes to positive infinity. So that's the type of question we can answer. That's called describing the end of behavior of the polynomial. Let's look at another one. Okay, again, you want to note what your exponent is and your lead coefficient. So lead coefficient in this case is negative 2. Okay, so that's negative. That means the right-hand side is going to go down first. I don't know what the left-hand side does yet until I look at my degree. Degree is odd. It's the number 5. Degree, remember, is my highest exponent. Lead coefficient is whatever is in front of that. Okay, so when I draw a little sketch of this thing, because it's an odd degree, the ends go in opposite directions. Because the lead coefficient is negative, the right-hand side goes down first. Right-hand side goes down, the other side has to do the opposite because of the odd degree. And then again, we just kind of look for that point in the middle, which would be here. And as x gets really big, where does it go? Let's trace it. It goes down. Down is negative y's, negative infinity. And then we trace it to the left. What's it do is x goes left. With tracing the function, it goes up. And that's the positive direction in the y, so that's positive infinity. And we're done. We've just described the end behavior. And so if somebody didn't have the function, and you told them this, they could say, well, as x is on this side, positive, the function goes down to negative infinity, and as x goes this way to the negatives, the function goes up. And they'd have a very similar graph to what you drew. without even knowing the function. Last one, it's again lead coefficient, 3. That's positive. And degree, highest exponent. Uh-oh, Mr. Todd goofed up. Look, it's not in standard form. In fact, our highest exponent is 6. That should be out front. So our lead coefficient is negative 4. Ooh, that's going to change things. Lead coefficient would be negative 4. So in standard form, this would actually be negative 4x to the 6. Then comes negative 5x cubed. Then the 3x squared plus 2x. Remember, standard form, we have to go in order of highest exponent to lowest. Our lead coefficient is negative 4, so it's a negative lead coefficient. Our degree is 6, which is even. Okay, the even tells us the ends go in the same direction. The negative tells us the right-hand side goes down first. And so right-hand side has to go down first, and left-hand side, because it's even degree, has to do the same thing. So as x gets really big, we trace it, and it goes down to infinity. So down is negative, negative infinity, and the left-hand side has to do the same thing. As x got negative, it went down. All right, so that's lead coefficients and degree to tell us end behavior. Next thing is kind of throwing that in with everything we've talked about. And so standard form we've discussed, degree we've discussed, lead coefficient we've talked about, end behavior we covered. Let's talk about zeros. Zeros are where it crosses the x-axis. And we talked about how we could find this by using a graph when we talked about it. But we said that didn't work very well, okay, because we couldn't read the graphs perfectly and we don't always have software. We got a new way we can deal with this now, though, because we've done a lot of other stuff. So let's go ahead and just see if we can answer these questions. Let's put this polynomial f of x in standard form. When you put things in standard form, remember, we don't add or subtract stuff. All we do is move stuff. So let's find our highest degree. There it is. So 6x to the 4th is the biggest term, our highest degreed term. Next highest is this negative 19x cubed. Next highest is the negative 18x squared. By highest, I'm just looking at the exponents. Then comes 73x. And then comes our minus 30. Let's shrink this down so we got room. Minus 30. So there we are in standard form. Degree, highest exponent. So this is a degree of 4. Lead coefficient, number in front. It's a positive 6, so we put positive 6 for our lead coefficient. We just put a 6. Name it by degree. Here's our degree list, okay? We've got constant. That'd be just something that is a number, no variables at all. Like f of x equals 5. Okay, then we have linear. That'd be something like f of x equals 4x. Okay, that's to the first power. We just don't show that 1. That's a linear. We have quadratic. These are our x squareds. Fx equals maybe 5x squared, something like that. We've got cubic. F of x equals negative 6x cubed. Okay, we've got quartic. A lot of you didn't spell that right when you were doing your homework the first time we went through. That'd be like 3x to the 4th. Okay, these are all named by the degree. And then we have the last one is called quintic. And that would be x to the 5th. So like 2x to the 5th. So, okay, after that we just call it 6th degree polynomial, 7th degree, 8th degree. In this case, since our degree is 4, this one we would call quartic. So we would just write for name by degree, we'd just write the word quartic for it. And then they ask if 3 is a 0 of f of x. Now, zeros just mean if I substitute 3 into my polynomial, I'd put it in standard form. If I find the f of 3, does it give me a 0? Okay, so to find out if 3 is a 0, you could substitute 3 into the function and find out if it gave you a 0. But we've talked about in this chapter the remainder theorem. And the remainder theorem said if I want to test the number 3, I could also just do synthetic division. Okay, what you're actually dividing by is x minus 3, and that means put a 3 in here. So we're actually, if you remember what we just did in class, is we were testing to see if we had a factor or not. How did we test to see if we had a factor? We would do division. So if I divide my function by x minus 3, and it comes out with a remainder of 0, then it is a factor. Okay? But we also learned if I do synthetic division with the number 3, the remainder tells me the f of 3. So I'm going to put a 3 in the box, and I'm going to list my coefficients, 6, negative 19, negative 18, and 73, and, oops, minus 30. I shrunk things down, it did not shrink. Sorry about that. And let's check to see if it divides evenly. So we'll drop our 6, and that's 18, that's negative 1, it's negative 3, that's negative 21, that's negative 63, and that's 10, and 3 times 10 is 30, and that's 0. So my remainder is 0, okay? And that is then the f of 3. Since I use 3, okay, the f of 3 is the remainder, which is 0. So in question 5, is 3 a 0 of f of x? Yes. And that also helps us to start factoring this polynomial, because this is what we've just been working on in class. I've got it started to be factored. I now know x minus 3 is a factor, and then the answer, remember, to my division problem. 6x cubed minus x minus 21 x squared x plus 10. So I've started the factoring process at the same time, just by doing a single synthetic division. All right, expanding binomials. Expanding means multiply them out. So let's look at how we could expand a plus b to the third power. Remember, this means to write a plus b times itself 3 times. Like that. Okay, let's go ahead and I'll just start distributing. Now, you could multiply the first 2 factors together first, ab times ab first, or you could multiply the second together first. It doesn't matter what order you put it in or do it in. I'm going to actually multiply the second 2 first, and I'll show you why. So I just distribute. A times a is a squared. A times b is ab. And I distribute. B times a is ba. I'm going to write it as ab so it matches there. And then b times b is b squared. The 2 I underlined are like terms. I've got 1ab plus 1ab, that's 2 ab's. And I still have this 1a plus b out front. I haven't multiplied it yet. The reason I multiplied the second pair first is because it just makes me feel like it's less work to distribute just an a and a b rather than distribute 3 terms. It really is the same math, it just feels better to me. So a times a squared. A times 2ab is 2. And then we get an a times a, because I'm taking this a times it, so I get an a squared. So we get a 2a squared, and then the b that's in there. And then lastly, a times b squared is ab squared. Next, we're going to distribute the b. b times a squared is a squared b. I'm going to line that underneath this a squared b term. Then I'm going to take b times 2ab, so they already have a b in there, so that's going to be 2ab squared. And then lastly, b times b squared is b cubed. Let's add any of our like terms together. It's a terrible looking a right there. So that's a cubed. This is 2a squared b's plus 1, so that's 3a squared b's. This is 3ab squareds, and this is b cubed. Whew. And we are finished. That is the expansion of a plus b quantity cubed. And that's all good and dandy, everybody. This is only a plus b to the third power, but we discussed also what happens if we have a bigger expansion. So this is 2x plus 3 to the fifth power. And you can see that this would take quite a bit of time to multiply all that together. And so we used a method called Pascal's Triangle. And I'm going to generate Pascal's Triangle again to help you guys remember. You start with a 1, and you just put 2 1s on the outside of it. You put a 1 on the outside, you add these 2 and put a 2 in the middle, and you put a 1 on the outside. You put a 1 on the outside, you add these 2, so we fill in the gap. Fill in the gap with addition, 2 plus 1, and then a 1 on the outside. And we just keep repeating this process. So if I can get that out of the way, we got a 1, and we add right there, so that's 4, 6, 4, 1, and 1. I've got enough room here. 1, then we get a gap. 5, 10, 10, 5, and then our 1 on the outside. And I'm going to stop there because this is a fifth degree polynomial, and I just got to the line that has a 5 in it. That's the one I want to use. So when we do this problem, I'm going to steal this line that has the 5. These are going to be numbers I have to work with. 1, 5. Note the gaps I'm making. We're going to need to have those gaps in there. 10, 5, 1. So I steal that to help me get my terms. And these are all the not the lead coefficients, because we got a little multiplication in there. But now here I want you to notice, this is how, if we have a binomial, a basic one, like a plus b. And I'm going to use the one that is cubed, the problem we just did. If I was doing this problem, its coefficients would be 1, 3, 3, 1. In fact, if I look back here to my answer I just had, you'll notice we have a 1, 3, 3, 1. It gave me those. I want you to notice also on our answer that we have here what the a did. The a went a cubed, a squared, a to the first, no a's, and the b did the reverse. Okay, if I start on the right-hand end, it went b cubed, b squared, b to the first, no b's. So the first term in your binomial starts with the highest exponent, cubed, and it goes descending, 3, 2, 1, none. The b, on the other hand, starts at the other end, b cubed, and it goes descending. Some people look at it as the a exponent goes descending, and the b exponent, it goes ascending. if you just always read from left to right. So if they look at it that way, they go A descends 3, 2, 1, none. B ascends 0, 1B, 2B, 3B. So let's look at what ours are going to do. In our case, we got a 2x is our A, so to speak. So the 2x is going to start with the highest exponent, 5, and then it descends. 4, 3, 2, 2x to the 1, and then no 2x's. And I always like to start from the right-hand end with my b's. In this case, b is my 3, and it goes 3 to the 5th, and then it descends in this direction. 4, 3 cubed, 3 squared, 3 to the 1st, and then no 3's. Or if you like to think of b as ascending, there's no b's, b to the 1st, so 3 to the 1st, 3 to the 2nd, to the 3rd, to the 4th, to the 5th. Okay, and now we could literally simplify each of these, and we would know the big expansion of it. But we're going to make sure we just answer the question. We just want to know what the third term is. Okay, well, this is the first term, this is the second term, and this would be the third term. We just got to simplify that expression. It's 10 times 2x cubed times 3 squared. And when we simplify, we follow order of operations, so we have to take care of exponents. 2 times 2 times 2 is 8, and x cubed is x cubed. And 3 times 3 is 9. So we got, now we can do multiplication. 10 times 8, that's 80. And then 80 times 9 is 720 x cubed. That will be the third term of this polynomial or this binomial expansion. And I think, let me double check here. I do not want to cover more material than you guys have on your assignment here for our first review. Let's see here. Part 1, we got one more problem we got to look at. Number 4 in your homework is Pascal's Triangle. Number 5 looks like this. We actually have already talked about this a little bit. Evaluate f of x, and they give you a polynomial, and they say x is -2. So a lot of you have been doing that substitution. You've been finding the f of 2 or f of -2. Okay, and you plugged in -2 and plugged in -2 and plugged in -2, and you did that, and that works great, and it works, but I also notice it takes you a lot of space. Instead, we use what is called the remainder theorem. And the remainder theorem basically says, if you take f of x and you divide it by x minus k, the remainder is the f of k. So in this case, and so what this means is, in our case, if I take my function f of x and I divided it by x minus the k value you want to use is whatever you're evaluating for, -2. So we're dividing by x plus 2, actually. Now that gets a little bit confusing for a lot of students. So to make it really simple, if you want the f of -2, use -2 in synthetic division. You want the f of 5, use 5. You want the f of 20, use 20. You want the f of negative 50, use 50. I want the f of negative 2, use a negative 2. It means you're dividing by x plus 2, remember, because we always use the opposite sign when we do synthetic. Then we just have to write down our coefficients. This is so much quicker than substitution. Be careful. There are no x cubes, so we got to put a 0 in. See, there's no x cubed. We go from 4 to 2, so we got to put a 0, x cubed, minus 3, 2, negative 5, and we do our division. 2, negative 4, oops, negative 4. When we add, then negative 2 times negative 4 is 8, that's 5, and that's 2, negative 4, okay, negative 10, it's negative 8, that's 16, and that is 11. So the f of negative 2 looks like it is 11, the remainder. And that's it. Let's go ahead and compare this. I'm going to brute force it. Erase. I'm going to do it the way some of you have done it to see if we get to the same result. Okay, so we could also do it this way. So we can compare f of negative 2 would be equal to 2 times, we substitute in, negative 2 to the 4th, minus 3 times negative 2 squared, plus 2 times negative 2 minus 5, taking care of exponents. It's going to be a positive 16. And it'll be negative 3 times a positive 4, and plus 2 times negative 2 minus 5. That's 32 minus 12 minus 4 minus 5. 32 minus 12 is 20, minus 4 minus 5. That's 16 minus 5, and that is 11. So it does check. We don't have to check it. I was going too fast because I thought I knew the answer already. It had to come out to 11. Anyway, I'll edit out some of that stuff. And I think that's it for, double check here. Yeah, that gets you to your review, everybody, for the first part of it. So 1, 2, 3, 4, and 5 is your assignment for the weekend.